Alright, so section 1.2, and this is our data basics. What are the big ideas here? Well, there's a lot of vocabulary here. And so it starts with this idea of types of variables, and that will be important if you go back and look at our introduction. I talked about continuous variables or numerical variables and categorical variables, and so on page 6 of your text, they mention, whoops, I'm not sure, I just erased all, oh no I didn't, went to page 2, somehow I hit something on here with my hand, went to page 2, and there, I fixed that. I guess the hand control or the skin control. So yeah, I have problems with technology at times too. So okay, page 6, all variables, and so here we have variables, and I want to point you to this chart. It mentions we can go one of two ways. We can go to numerical, and we can go to categorical. Now, numerical is usually pretty straightforward. One way to look at it is numerical. Does it make sense to talk about the average? That is, I think, a reasonable way to look at numerical. Okay, so we're here at numerical. Does it make sense to talk about the average? So we had mentioned in the introduction height and weight, average height, average weight. Those make sense, and so yes, numerical. Categorical, on the other hand, typically an average wouldn't make sense. So things could even have an order. So if you think of things like street addresses, usually they go in a nice order. If I'm in the 100 block, I'm usually very close to downtown or in downtown in a city or town. And if I go out to the 1200 block, I'm usually heading out of town or truly out of town, something like that, in the city or town. And so, it doesn't quite always, it doesn't always work that way. Sometimes things are really messed up. But same thing with floors. Now at Lindsey Wilson College, if you're in, what is it, I think it's Phillips Hall, numbers there make little to no sense. But in most buildings, right, if I was on floor 2, I would know I'm above that if I'm in floor 4. So there's an order to it, but it probably doesn't make sense to talk about the average floor, right? Oh, I was on the first floor twice, there's 2 1s, and I was on the second floor once, there's a 2. Now add those numbers together. 1 plus 1 plus 2 is 4, divide by 3 is 1 1/3. Oh, on the average, I was on the 1 1/3 floor. That makes no sense, right? So, floors, even though they go in order and we do use numbers, we would still call those categorical and not numerical. And so, if it makes sense to talk about the average, there's a good chance it's numerical. If it doesn't, there's a good chance it's categorical. Again, there's some kind of iffy things. If you start talking about people's ages, so I have, I bring people in my data as their age to the year, so they're 6 or they're 7 because I'm working maybe with children on some study, and or they're 8, and in that way, sure, you can talk about an average age, and I would be fine with somebody telling me the age was numerical. But on the other hand, well, are all 6-year-olds actually the same age? Because all of a sudden one day, one kid's now a 7-year-old and the other one is still a 6-year-old because of birth dates. And so in some ways, if you talk about ages like that as 6-year-olds or something, well, it could be categorical. So there are a few things that get kind of iffy, but most of the time, again, it's pretty straightforward and reasonable that if you think about being able to take the average and having it make sense, then you're probably talking numerical. Okay, under numerical, we have continuous, and we have discrete. So discrete are things that do happen as integers, typically for our data. So you could keep track of, say, the number of trees in a field, and that would be discrete, or the number of people. That is discrete because we don't have half a person. And so usually when I'm counting up objects, I'm probably going to get something that's discrete, whereas if I'm measuring things like time, space, like area, that kind of thing, it's more likely it's going to be continuous. Now, I could round continuous numbers to be more discrete, kind of like ages. Ages are not really discrete things because they have to do with time, but we tend to round or even truncate, that kind of thing. I'm 59 until I'm not, and then all of a sudden I'm 60. But if you talk to little kids, they're usually pretty quick to tell you, oh, they're maybe 5.5 as opposed to 5, because they see themselves getting closer to 6 and they want to be, and so they might use fractions and so forth that way. But so we have continuous and discrete. Again, things like time here, and here this would be number, usually number of objects. So I'm counting trees or counting people or something like that. Now, categorical, your text, they put this in sort of faded print, and my guess is maybe because they don't worry about it too much in the text. We don't worry about it a great deal. They mention regular categorical. So this is things like color. Blue, green, red. What order? Well, I don't know. I mean, you could, I guess, talk about order in a rainbow or something, but typically when you think of real categorical variables, you don't think of being able to put them in an order. And that's an important thing to realize, is that we may have them in some order, but they are not. And that's where you have to be careful. So for instance, if you're talking about colors of people, you don't want to put them in a way that you're trying to say that one color is somehow better than another or higher than another. Religion, very much the same way. I mean, you may believe your particular religion is very important and it is the right way and so forth, but when you're talking about data, you don't want to put, say, one religion as higher than another one, because a person in a different religion would be just as sure of their religion as you are of yours, and so it doesn't work to put them in order that way. But there are things that are ordinal, or you can put them in order. And, so these would be things like addresses. We can usually put those street addresses in order. Other things like small, medium, large, right? Small, medium, large, something like that. Those are ordinal because small is smaller than large. Well, how much smaller? Well, it depends. If you go to one store, small is a lot smaller than large. At another store, maybe not much different. And so, we can put them in order, but you also have to be careful about what you mean by that order. So there is a bigger or a smaller or a higher or a lower or something like that. But it may be that a large is not twice as big as a small. It might be 3 times as big as a small, or it might only be 1.5 times as big as a small. Again, we don't know. They're just categories. Okay, so those are our 2 types of variables, numerical and categorical, up here. And then within those subtypes, we have continuous numerical and discrete numerical. And then we have our regular categorical and our ordinal categorical. So those are the types of variables that we have. They point out another word. I'm going to toss it in here just because I know a lot of people use it incorrectly. Nominal. Nominal means in name only. Now, you possibly, or someone you know, tends to use nominal like the word average. Okay, oh, the nominal case is, and then they make it sound like average. That's wrong. That is not what the word means. The word means a name only, and so, for instance, if you know much about construction materials or something like that, we have boards that are called 2x4s, 2 inches by 4 inches. Well, that's actually nominal. It's in name only because they are not 2x4s. Almost exclusively. Typically a 2x4 is somewhere around 1.5 inches wide, not 2 inches wide, and then by 3.5 inches, not 4 inches deep. And so that, if you say, oh, it's nominally a 2x4, that is absolutely the right use because it's in name only. And your textbook points out that categorical variables can also be called nominal variables, or regular categorical could be called nominal. And when you think about like colors, blue, green, red, well, why blue? I mean, why couldn't that instead be some other word, right, instead of blue? Right? It's in name only. We recognize the name and we think of the color, but we could quickly change that name if we could get everybody on board. Okay, so they mentioned that. And I think, let's see, I think that's about it. They go on in this section to talk about relationships between variables, and they mention they get down to page 8, and they talk about what we did is there's either a relationship or there's not, and so at page 8 at the bottom they point out and they say associated. Okay, they're associated. Now, I'm not sure why they don't just go ahead and say dependent, but they say associated in a nice little box at the bottom of page 8, and then they say or they are independent. They are not associated. But notice they didn't use the word correlation. Okay, again, correlation is a very technical term. You want association or associated, dependency, something like that. They are related, words like that. Try to stay away from the word correlation until we get to chapter 6. Okay, so that's quite a bit on variables in section 1.2, and so we'll move on.